I'll be giving the bi-weekly contest 167 live, and this will be the recording. So this is a virtual contest that I will be giving because I have missed this contest. This was on October 11, today is October 15, so yeah, I'll be giving this contest and let's just see how it goes. So yeah, it has been a while since I gave a contest, so I'm just trying to, so what will happen is that I'll try to go through the problems as fast as I can, so I'll be solving them, but I won't be explaining them. And then after I'm done with the contest, maybe after 1.5 hours, then I'll be explaining the problems as well. So yeah, let's see how it goes. So I'll be starting it now. Okay, we are joining it. This might open the first problem, so I'll just open the rest of them. Okay, so we are given a string as of lowercase English letter. The score of a string is the sum of the positions of its character. Okay, determine whether there exists an index I such that the string can be split into two non-empty substrings that have equals to scores. Okay. Alright, so a plus d and b plus d. Okay, cool. That is not a hard problem for us, but let's just see how we can go. Cool, this is not hard, very hard. Okay. So I'll just maintain a prefix of values for us, and n is basically the length of the string. So what we are going to do is we're just going to iterate first of all for the length, and just have prefix of I is equals to s of I minus a, and then we'll just if I is true, then we'll just have. Okay, cool. So what we're going to do is we're going to iterate for every single line. So we need to split it into two substrings, right? Two non-empty substrings, so it has to be this. So current will be psi, and the left prefix of. So basically we have to have that position. So we'll just have to subtract it because we don't want to include it. So that will be just that. Minus 1 minus prefix of I, and then we just have to see if double equals up. Just return true. Otherwise return a false. So it's a true and it's a false. Should work now. What the hell? Two non-empty substrings that have equal scores. Okay. Wow, that is not very good. Cool, that is fine. That is not a problem for us. Okay. We can. Oh. Yeah. We can do this. Right, we can do this. Just add that. Yeah, that is doable, I think. Oh my god, no. This is because we are considering all the substrings that are there, but it is not very true for us. That sucks. That is a very bad start of the contest, but okay, whatever. Let's see what we can do. Well, this problem can go to hell. You're given an length of the longest Fibonacci sequence in nums. Alright. Since the numbers are very small, so we just don't have to care about that. Yeah, we don't have to care about that. It won't be that big, so yeah, whatever it is. I mean, sections of something we can always do. So yeah, Fibonacci sequences become very big. So we can calculate a maximum value, which is maximum score. Or maybe we can do binary search. because if certain sequence is a certain length is present. Yeah, we can maybe do that also, because if we are present, something will be present, then obviously we'll have to check for greater one because that will be present also. Yeah, okay, cool. So we can form a Fibonacci. Let's just call it subrays of length 1 or 2 are always Fibonacci. Yeah, obviously there are. Currently we can return 0 bus. It can be some length. So we can just see this is a good problem. So yeah, as you can see, the length won't be that big if that is that, so we'll just iterate for that length. The length can't be 0, so okay, cool. Then we have to obviously increase it, so we'll just do this, else reduce it. We can just return it. So what do we check? When we do a basic operation, we can just check length. Oh yeah. $45 is crazy. Okay. Yeah, well then we have to make this minimum of. Okay. Interesting as well. Okay. I feel like I'm fine, to be honest. We're checking for 4. 4 doesn't work. Yeah, well, I don't really even need to do that. I can just check for every single value. Oh, it has to be a section of the Fibonacci. Damn, that changes things. Well, okay, well, if it's a section of the Fibonacci, then obviously the last two, it has to be the sum of the last two ones, right? So, can yeah, this was a bit complicated. I don't think we needed this. Okay, we took 5. We took 5. All right. Okay, cool. Well, they can go to hell. I don't really care. Okay, it shouldn't have been 0. Oh. Oh, this is not even that hard. I made this so hard. Design exam score tracker. LS frequently takes exams and wants to track her scores and calculate the total scores over the specific time period. Okay. So initializes the exam void record, and Alice takes a new exam at time and achieves a score. This okay. Long total score returns an integer that represents total score and all the exam taken by Alice and start time and inclusive. Okay. So they are strictly increasing time. Okay, we need to find out the total score in that position. Interesting. Okay. All right. So basically, we need to find out. Cool. And this isn't strictly increasing time. Okay. Calls to record will be made in strictly increasing time, so we'll always be adding the elements that are strictly increasing in our basically position. so this has to be strictly increasing. All right, total score searches. Cool. How many queries will there be? Well, regardless, whatever. Total score. All right, so yeah, so we push in a time and a score inside our thing. Yeah, and the time will always be increasing. Yeah, so the time will always be increasing. How many queries we have, how many things we have? At most 10 to the power 5 calls will be made. Okay, so it's easy for us to find out the score and the time. But how do I calculate the prefix fast? Well, in order to do that, basically we have to formulate a way. You know what I mean? So yeah, so basically we push the time and we push the score, and then we need to find out oh yeah, it can be done. It's an easy problem. So basically we are going to define two things here. So time can always be integer. Let's just call it t1, and then we are going to have a prefix, which has to be a long. So we just do t1 dot clear, t dot clear every time we are doing this. So what we do is t1 dot push back time, and t2 3 dot push in the score back score, and if 3 dot size is greater than 1, then we just do 3 dot back plus equals 3 of 3 dot size minus 2. So we basically add that to our value. Yeah, so that's how we're going to do it, because if it's 1 then we don't need it. And then we're just going to do a query. So they are both inclusive. So first of all, I'm going to find the index of the start time. So it has to be the lower bound of our time array and the end of the time array, and the start time will be the parameter minus the begin of time, and we'll also found the end time, which is the lower bound of time array and end of time array, start time, basically end time. So we are going to find the lower bound, but this lower bound can be also at a position that is greater, so what we have to do is first of all we have to check well, I think it would be better for us to just have this id1, we can do id2 here. So we can just remove this for time being. Why we're doing this, we'll explain. So first of all, we have to ensure that if id1 double equals n, or id2 double equals n, return 0. Now both of them are inside the array, right? So we'll just check that if star of id2 is basically greater than end time, then obviously we'll have to push id2 minus. Okay, yeah, but we can have a start time, it's a hard thing to find out the first position that is. So basically we need to find out the first position for both of them that is inside the array that is greater than or equal to, well, the start time has to be greater than or equal to that is, I'm just going to do two binary searches here. I don't really know. And R will be the title size. Since we are not including that, so that will be alright. We don't really want to include n, right? Okay, cool. So it will be from 0 to title size minus 1. Just middle. We'll just check that if time of m is equal to start time. We'll just do r equal to else r equal to. So id1 will be r. Similarly, we'll just do it again. I know this is repetitive code and this is not a good practice, but so if time of m is basically less than end time, so nowhere else if it is greater than equals, then we'll move it to the back. So this will be id2 will be r. So now we have to make sure that it has to be we know that okay. Yeah, I mean that is almost the same thing we're doing here, but here what I'm doing is I'm checking that if it is less, then we move it ahead, and if it is more, then we move it backwards. So we only care about the okay, we can actually do it like this. If it is less than or equal to, we move it ahead, otherwise we move it to the r. So now this will be l. So we'll basically just check that id2 is less than equals to less than id1, then we return 0. Otherwise we just return prefix of id2 minus prefix minus id1, then prefix of id1 minus 1 is time no size. Oh yeah, it has to be t1. Okay, do I have it anywhere else? It should be t1. Null 98 null 98 ones. Okay, this is fine. Cool. Maximum partition. Oh yeah, we'll have to do first one also. Yeah, what was the problem? Determine whether there exists an index I such that the string s can be split into two non-empty substrings as 0 to si plus 1 minus n. Oh, we have to include I. Yeah, that's what I'm doing here. Sum of the positions of his character in the alphabet. I think that is pretty fine what we are doing. Okay, I can that doesn't really change anything, but okay. There was something that was going wrong for us. Yeah, so this should be false only, right? Oh my god, just putting a 1. God damn it. I think it's because whatever, man. Yeah, so let's continue. You're given a 2D integer array points of I represents the ith point in the Cartesian Manhattan distance. Okay, we know the Manhattan distance. Split n points into exactly two non-empty groups. The partition factor of a split is the minimum Manhattan distance. Minimum Manhattan distance between another player that lines up. Maximum possible partition factor. Cool. So yeah, we have to split them into two groups, right? So yeah, okay, cool. Yeah, so we can obviously binary search on the answer. So we can binary search the maximum partition factor that we have. So how do we find it? So basically every partition, every possible partition has to be greater than our minimum Manhattan distance. So let's just say that L is -1, R is I don't know, some very big value. So let's just keep it since it's that, so we'll just keep it like this. I don't know why. Okay, if it is a good one, then obviously we'll have to increase it, else we decrease it because it's not good. So then we'll return this tab. Good equals value, so whatever value that we have, so with ourselves. So yeah, so initially what the value that we have is, wait a minute, oh my god, it had 16,000 souls. Well, that was an easy problem. I don't know why I complicated this one, but I'll explain why I did complicate this one. This was an easy one. Yeah, so we have a value, and then we have to push basically split it into two groups such that so when we have okay, so we are going to form two vectors. Yeah, we're gonna have A and B for the representing the two groups. So every we can put any vector inside any vector, and then we have to just make checks. So what we need to check? We need to check that since we have a value, and this value is basically the maximum possible partition factor. So this is the minimum value that exists. So all the values that we have, they have to be greater than this. Otherwise, so basically we have to check that all the pairs form a Manhattan distance that is greater than that. Okay, so we'll just go inside our. So what we can do is basically, yeah, so we can push this inside of our points. So now what I'm going to do is basically for every integer we have two choices, right? But then it can affect the other one, but obviously we'll be able to have to put it in one, so we'll also have that liberty with us. So we'll create two booleans, basically bool OK1 equals 0, bool OK2 equals 0. We don't even need this, I think. So basically both of them are 1 initially. So what I'm going to do is I'm going to go inside RA, and then I'm going to go inside RB. So what I'm going to check is that the Manhattan distance, I did this, we'll calculate this by doing the absolute values for the points of I, 0 minus x of 0, and okay, so it's a 2D array, right? Well then, yeah, it's a 2D array, so I'll just do that. So absolute of points of I, 0 and absolute of, well, basically we can just create a function here. Return F0. Yeah, so this function can tell us the distance between points of I, a, basically x. So if distance basically the distance is less than the value, OK1 is 0, and then we break it. Similarly, we'll do the same thing for this, but this time we'll just have to do this. So if OK1 is true, then what we're going to do is basically false. It's not true. If OK1 is true, then we just basically push it inside our first vector, so we'll push the points. So the first vector else will push the points inside our second vector, which is the b1, and this should give us our answer. So it says 4 and 11. Oh my god, no, it's not for 11. Okay. This should not have worked, but let's see what happens here. We're returning a true. I need this. What happened here? So we split it into two groups. Okay. That is not a. Okay, I understood what they're trying to say here, but yeah, we can end up. Basically, we can just do this: if OK1 and OK2. So we'll just see that if it is size less than b dot size. And then in the end, we also have to return that. Otherwise, they would nullify to 0. Okay. I need to push. Oh, what happened? Okay. Oh yeah. Wow, 1, 2, 3, 4, 5. Okay, let's see what is going on here. What the hell? What is this? I'm putting a 0 here. I hope that is clear with you. Okay. Yeah, but in some cases we can just throw away that. Let's just run it for 4. Why is it a -1 and isn't even? It returns before. So if this is true, then this is true. If both are good, If none are good, then obviously we return a false. We do this 2 times for us. It should have. Oh, okay. Not considering all of them. But that doesn't really. Oh, okay. Cool. So it's working here, right? If I put a plus. Let's see what we can do here. This is a very bad code, but 1 2 3 4 5 4 and minus 1. Okay, so what happened here is that oh, okay, cool. So it contributes no payouts. Cool, let's see if it works. Yeah, this case. Oh, okay. This would work. That would be great. Okay, it is not working as expected, but it should have worked, but it's not working. Great. So now I have no other choice but to debug it for this particular case, I believe, because then I don't really have any choice. 1 2 1 5 6 3. Yes, why did you fail? Where did you fail? Apparently you must have failed somewhere. Wait, how big are the points? Oh, they are not that big. Shouldn't be a problem. Okay, so we iterated 2 times and then we didn't really have any choice but where to put them. Cool. So we can also print out the size of the 2 vectors. Yeah. And then we can actually make this an asterisk now. Let's see what happens. Okay, so the size first of all was 0. Okay, maybe we can just push it here, I believe. Okay, cool, we can just do it here. Okay, so it was 0 1 and then it was 1 1, so this was there, but we didn't have anywhere to put this. And why is that? I mean, one of them has to go. Okay, well, both of them don't work with each other, I guess. We have, okay, one, but also have okay, 2. How about this? Okay, so both of them are working, and on the second case also both of them are working, so we pushed there. But then again, we don't really need, we don't really care, you know. If I just randomly push it, maybe it works now. Okay, so I can do that, but it might lead to some unpronounced results, you know. Why is that? Because we don't know what is going to happen then. So I will copy this test case and I'll reset them, and then I'll copy this. maybe I'll just copy this one also. 1 2 3 4 5. Oh my god, 1 2 3 4 5 6 7 4 11 this and 0. I mean, there are very low chances that it might work. Yeah. So the thing is, why it is failing is because it doesn't really know where to put them. But I would say that there's a case that if OK1 and then OK2, then it's a good idea to put maybe just maybe it might work, it might not work, because yeah, they expected something else and we gave them something else. It's because of the positioning of the elements that we are putting here, right? So we need to put them so that the minimum collisions happen. So okay, so it's like cool. So each subset can be a part of any of the two, right? So it can be a part of the first one or it can be a part of the second one. We have a we have a choice of where to put it, but putting it is it matters because we can't just we can't just randomly put it, because that might lead to a bad set that was occurring. So what happens is that, so so randomly putting it, basically what it does is that, let's just say that the first set had bad elements. Let's just say that we are considering the current element, which is the points of I, and let's just say that the first set had a bad element, okay, and on the previous iteration we pushed a bad element also inside the second set. So we are not able to push now our element in either of the sets, but what we could have done is that basically that you know mm-hmm. Yeah, so basically we have a bad element in both of the sets. What we could have done is that push the first set, the first element inside the first set, given that it was a good element for the first set, and then we will be clear for pushing the current element inside the second set. So this is randomly putting it, is giving us errors. So we, I don't know, there so this is random, right? So it's hard to figure out. It's hard to figure out where to put the element. Low key, that's where we are having problems. So maybe what we can do is try to figure out try to figure out what we can even do. I don't even know. Yeah, well, I think about when I think about it, I'm thinking and I'm seeing that there has to be some way. How can we partition them? Well, binary search is a good thing. Maybe it's some kind of a trick or something. Is it like a commonly known algorithm or something? Do we need? Is it like bipartite? Is it like a graph? Because we are either painting them red or this could be a graph problem. But how do we make the? This is interesting. Ooh. Okay. Interesting. Okay, I think I got it. I think I got it. So let's just say that, okay, I think I got it. We can do a bipartite check in this way. So first of all, we have to do a calculation, which is the D. Okay, so we can do this like this, D and the N. D of I comma j equals function of points of I comma points of j. So this basically calculates the Manhattan distance between every single set of points. So now we know that what all points are good and what all points are bad considering our current value. So if we form a graph with those, will we be able to formulate something? So now we know that what are bad and what are good. So we need to form a connected graph. We need to form a graph which is bipartite. Okay, and it is formed by all the pairs that have their value. Yeah. So in that way we can probably do this. Right. So we can run a bipartite check, basically connecting it to all the edges. Got it. I got it. So let's just say that we have a color array. Simple bipartite thing. So we'll just do this and we'll just check if the color of I is -1, then we run that. If not, we first I comma 0 comma DFS and return a false, because then the bipartite is not possible, otherwise we return a true. And then our DFS function is like color, and also I'm going to dfs, which returns a boolean. So what we are going to do, we're going to simply color the node as color, right? And we'll go to all the neighbor which runs from 0 till n again, and then we'll just do a neighbor plus plus, and we'll just see that if what the hell, if the color of the neighbor is -1, then we are just going to check that if dfs of neighbor comma color the other color dfs returns a false, then we return a false. Else if the color of the neighbor, and then we just check that if color of neighbor is equal to the color of the node, then we again return a false. So this is the simple bipartite check. Otherwise, if everything is good, then we return true. Okay. Just working. Oh yeah, we cannot form. But we also have to check if that is a conflicting edge. So we only have to do this. Okay, we need to pass a value also, because we only need to do this if it is a conflicting. If it is not conflicting, then basically they have the same thing, right? Also, if node is equal to the name, then we don't need to check anything. And if the distance between the node and the neighbor it is less than value, then there is a conflicting edge, so we do whatever we were doing. Yeah, we don't need memset. What happened? We don't need this memset here. That should work now. Color, okay. Yeah, so we can define this here, and then we can just reset color every time you're going through it. It should be a color. Okay, that's a lot of errors. We'll do this. Cool. So we have 4, 11, 1, 2, 1, 5, 3, and this should work now. Cool. So we're done with the contest now. So yeah, that was the contest. We had a pretty bad start, but I think we were able to complete it, so it's fine. Okay, so now I can explain these problems in a bit more detail. So the first problem was basically we have to find out if there exists a partitioning of the strings such that the first string and the second string have the same sum of values. The sum of values is calculated by summing up the values of the alphabets. So earlier I was doing s of I minus a, which gave me a wrong answer, and that is because for a it considered 0, and I think it had some absolute errors, so I think that was because of that. But regardless, what I did was I calculated the prefix sums for all the values, and then I just iterated from 0 till n minus 1, because it was told to us that we need to have 2 non-empty substrings, so I stopped here, otherwise we'll have 1 empty substring. So that was that, and then I calculated the current value and that value, and then yeah, if they were both equal, then I returned a true. So this can also be done in a brute force manner, where we can just calculate them both, but I think I think both are almost equal in complexity because this length is too small. Yeah, the second one, I overcomplicated this problem a lot. So, but this was an easy problem. All we had to do is maintain an answer array which was 2, and the current iteration that we were keeping was 2, and then we just checked that if our current value is equal to the sum of the previous value and the current value, then we incremented this and updated our answer. Otherwise we set it to current again. So that was that. This was an easy problem. Yeah, so in this problem, this problem was also not very hard. So what I did, so what we basically had to do is we were given a record which basically tells us that at this time a girl scored this much score, and this was given in an increasing order. So that gave us an hint that we can binary search because we are storing them in increasing order. So I formed two arrays, where one was for storing the time and one was for storing the values, that the value of the scores that the girl was getting. And this I did because we needed to calculate the total score between two timestamps. So we can do that by doing a prefix sums if we know the indexes. So the first array I posted the time, and the second array I just created a prefix sum. And after that I just did a binary search to find the first index. So basically id1 stores the first index that is greater than or equal to the start time, and id2 basically stores the first index that is less than or equal to end time. And then I just did a basic check that if basically the index for the end time has to be greater than or equals to id1. So I just did this check, and if it was smaller, then obviously no answer is possible, and if it is true, then we just return the prefix sum. So this was also an easy problem. Yeah, so maximum partition factor, this was a good problem. So seeing this, it's easy to have this idea in our mind that okay, we have to apply binary search because we have to find the maximum minimum value. So that is something called the binary search on answer. So I created two answers which were these, and then I did the binary search, and there was a good function. So basically what we are doing here is that this is basically the answer. So this is the maximum possible partition factor. So what we are checking here is basically that this good function basically checks that for a group, every possible ordered pair should have their Manhattan distance greater than or equals to value. Why is this? Because if the Manhattan distance is less than value, then that would become our minimum value. So minimum value will be MD, and that would contradict with our assumption that value is the maximum minimum partition answer. So in order to check this, first of all, I was adding both of these into two groups, and that there was a randomness factor that I explained while solving the problem. So what I did was I did a DFS, and in particular what I basically did was, okay, let's just say if we are able to form a good grouping for all the pairs, then some pair will be in the first group and some pair will be in the second group. So that gave me an idea about bipartite graph, because we have two colors in a bipartite graph. So what I did was I iterated for every single I, and then I just did a bipartite check. So while doing the bipartite check, I basically colored the node, the familiar bipartite algorithm, and then I also checked if the current node that we are checking is not equals to the node that we have already checked. And I only checked the node if it was a conflicting pair. Now by a conflicting pair, I mean that the value between two of them is smaller. If the value is already greater, then we don't need to basically put we don't really need to do anything for that pair, right? So if the value is smaller, then we need to make sure that the current node and the neighbor are in two separate groups, otherwise they will conflict. So basically I did that only, and in order to check that I ran a DFS. So if the color of the neighbor was -1, then I just gave the neighbor the other color, and if that DFS returned a false, I returned a false. And if the neighbor had a color, then I just checked that if the color of the neighbor is equal to color of the node, then we know that they are in the same group, and if they are in the same group and they are conflicting, then we return a false. So yeah, this was I think identifying it as a graph problem was a hard thing for me to do because I did a lot of wrong submissions. So yeah, and yeah, there were a lot of wrong submissions for me in this contest, but I think we did just okay because I haven't been doing Leetcode for a while, but there is always a scope to improve. So yeah, that's it for this contest. This was Biweekly 167, and yeah,